So hello students, welcome back again to MRS Math class. Hope you are fine. So today I am going to discuss about some more problems on non-homogeneous linear equations with constant coefficients, right? So last class already I have discussed some problems as well as some theories, right? So here I have collected some more problems which are of different types, okay? And here I have taken some new formulas, okay? And I am going to show you that when we can use this formula, when the problem will arise, so that we can apply this formula to solve this type of problems, okay? So let us solve one by one all these problems, okay? So first one is 9d square minus 12d plus 4 into y equal to e to the power 2x by 3, okay? So this is obviously a non-homogeneous equation because right hand side there is a function that is e to the power 2x by 3, okay? So already we have discussed about the complementary function, right? Here we have to find both complementary function and particular integral, correct? After that we have to take the sum to get the general solution, right? So first of all, for complementary function, okay, and that is what we have to do, that is 9d square plus 9d square minus 12d plus 4 equal to 0, right? So from here we have to get the root. From there we can say what will be our complementary function, right? So this is in the form of 3d whole square minus 2 into 3d into 2, right? 2 to the 4 into 3, that is minus 12d, right? Plus 2 whole square is equal to 0, right? So here you can see that this is 3d, right, minus 2 whole square equal to 0, right? So you can, what we can write, d will be 2 by 3 and 2 by 3, that is 2 times repeating, right? So this is real and repeating 2 times. So what will be our complementary function, or yc? We can write e to the power 2x by 3 into c1 plus c2x, right? Since this is repeated 2 times, so c1 plus c2x into e to the power 2x by 3, right? So this is our complementary function, correct? Now we will go for particular integral, right? Which is important, right? Here you can see yp will be equal to e to the power 2x by 3 over this one, 9d square minus 12d plus 4, which we can write 3d minus 2 whole square, right? This way we can write, correct? So here you can see what our formula says. We have to put whatever e to the power ax, right? Whatever in the place of a, we have to replace in the d. But you can see if we are replacing d as 2 by 3, then this part is coming as 0, right? So here problem arises, correct? So to avoid this problem, here we have to apply this formula, that is 1 over d minus a whole to the power n e to the power ax. If it is in this form and this denominator form is coming 0, then we have to apply this one, x to the power n over n factorial e to the power ax, right? So what we can write here, directly we can write x to the power, what is n? N is here 2, right? So we can write x square over n factorial, that is 2 factorial means 2 into e to the power x, that is e to the power 2x by 3, correct? So this will be our particular integral, correct? And here this is complementary function, okay? So our general solution will be equal to yp plus yc, okay? So you understood when we are using this formula, that is when this part is coming as 0 after replacing this a, that means 2 by 3, so this part is coming 0, so we are applying this formula to get the answer, okay? right? So now we'll proceed for the second problem. So now we can see the second problem, that is dq minus 5d square plus 7d minus 3y equal to e to the 2x cos hyperbolic x. Obviously this is a non-homogeneous, but here in the right hand side cos hyperbolic function is there, right? So we'll see if one hyperbolic function is there, then how we can get the particular integral. Okay, so first of all we have to find the complementary function, right? So what is the problem? That is dq minus 5d square plus 7d minus 3 is equal to 0, correct? So this is a cubic equation. Here you can see if you are putting 1, d as 1, then this part is coming as 0. So 1 is a root here, okay? So you can write a factor d minus 1, okay? Then if you are taking d minus 1 common, then what we will get? This is d square, then minus d square is coming, and then but we need minus 5d square, right? So d square minus 4d we can write, okay? Then this is minus this is plus 4d is coming, so we need again plus 3d, so we can write here 3, so we can write 3d, okay? So this is equal to 0, okay? Next line will be, this is d minus 1, okay? So here we can write d square minus 3d minus d, okay, plus 3 is equal to 0. Then we can get d minus 1. This is, if you are taking common d, then this is d minus 3. Again from here minus 1, if you are taking common, this is d minus 3, which is equal to 0. So the roots are d minus 1, okay, d minus 3 into d minus 1 equal to 0. So we are getting the roots as 1, 1 and 3. 1 is repeating 2 times. So complementary function will be, or yc we can write as c1 plus c2x into e to the power x, correct, plus c3 into e to the power 3x. Okay, so this will be our complement. This is our complementary function, right? Now we'll find out what will be our particular integral. Okay, so how we'll get, that is yp we have to find out from here, right? So that is e to the power 2x cos hyperbolic x divided by this one, right? So this is in the factor way, we can write as this, that is d minus 1 whole square into d minus 3 we can write, correct? So which is equal to e to the power 2x into cos hyperbolic x is there. So what is the formula? How we can do this cos hyperbolic? We have to first convert it to exponential function, right? Easily we can do that because we know the formula. Cos hyperbolic x is e to the power x minus e to the power minus x by 2, right? So here we can apply that formula, that is e to the power x minus e to the power minus x divided by 2, and this is d minus 1 whole square into d minus 3, correct? Again, so if you are multiplying e to the power 2x into e to the power x, what you will get? E to the power 3x, right? So 3, if you are putting here, this is 3 minus 1 whole square, right? This is 2 square. So what will get? 4. 4 into 2 is 8, right? Into d minus 3 is there. But if you are applying 3 here, then this is cancelling 3 minus 3, right? So we cannot apply that one. Again we will come to this formula, that is if it is in the form of 1 by d minus a to the power n e to the power x, then we have to, what will be the answer? That is x to the power n factorial e to the power x, correct? So here what we will get, that is x to the power, what is n? N is 1, so x by n factorial, right? That means 1 factorial is 1 into e to the power 3x, correct? So now minus is there, right? So minus e to the power 2x into e to the power minus x. So it will cancel. What we will get? 2x minus x is e to the power x we will get, divided by 2 into so this one we can write 1 minus 3, that is minus 2. Minus 2 into 2, that will be plus right? So plus 4 we can write directly, but here is the problem, that is 1 minus 1, it is cancelling. So again, if you will apply this formula, x to the power n we will get, that will be x to the power 2, correct, by 2 factorial. Okay, so this will be our yp. Okay, so our final solution will be, general solution will be yc plus yp. So yc we are getting as this one, and yp we are getting as this one. Okay, so by taking the summation we can get the general solution. What we did here, only problem is that here, that is because hyperbolic function is there. Since hyperbolic is there, we just converted into exponential, then easily applying the same method we solved it. Okay, hope you understood. Now we can proceed to question number 3. Okay, so now we will see the question number 3. Okay, so what is there? Question number 3 is dq plus 9d into y equal to sine 3x. Okay, sine 3x is there. Okay, let us see. So first of all, we have to find the complementary function, correct? That is dq plus 9d is equal to 0. Okay, so if you are taking d common, then what you will get? D square plus 9 is equal to 0, right? So we are getting d as 0. Okay, and plus minus 3i, right? D square plus 9 equal to 0. So what is our complementary function here? That is c1, right? c1 into e to the power 0x, so that is c1 plus c2 cos 3x plus c3 sin 3x, correct? So this is our complementary function, where is there is no problem, but problem it may arise in the particular integral. Okay, so what is there? Question is yp will be equal to sin 3x divided by this one, right? D into d square plus 9. Okay, so we can see that 1 by d square plus 9 is there. Okay, so 1 by d into sin 3x, right? So 1 by d into sin 3x. So already I discussed about 1 by d is the operator, right? So where we have to do the integration. Okay, so what we will get then? 1 by d square plus 9. So sin 3x integration will be minus cos 3x divided by 3, correct? So what we will get? That is minus 1 by 3 into cos 3x by d square plus 9. Okay, here you can see in place of a there is 3 cos 3x, so that should be minus 3 square plus 9. So minus 9 plus 9, again it is coming as 0, so we cannot apply this formula. We have to see this formula. It is in the form of this 1 by d square plus a square. What is a here? This is 3. So 1 by d square plus 3 square into cos ax. Cos ax is there. So this formula directly we can apply. So what will be then the answer? That is x by 2a. Okay, so x by 2 into a, that is 2 into 3. Okay, so this is 6 into sin ax, correct? That means sin 3x. Okay, so finally we can write x by 18 into sin 3x. Okay, so this is our yp, where we have used this formula. Reason is, here if you are putting 3, then denominator side is coming as 0, so we cannot apply. So we have to apply this formula to get the answer. So general solution will be yc plus yp. Okay, it is very simple. Now we will proceed to the question number 4. Okay, so now we will see the question number 4. Okay, so what is that? That is d square minus 4 into y equal to cos square x. So what is the problem here? here right hand side square is there. Okay, we know cos ax formula, but it is cos square x. So that one we have to apply the formula, that is 1 plus cos 2x by 2, right? Because we know the formula, that is cos square x is 1 plus cos 2x by 2. Then after that we can solve it easily. Okay, so let us solve. The first one is we have to find the complementary function, correct? So it is the root, then d square minus 4 is equal to 0. Then our d will be plus minus 2. Okay, so yc will be c1 e to the power 2x plus c2 e to the power minus 2x. This is very easy, right? Now we will come to the particular integral. Okay, what is this? That is cos square x over d square minus 4. Okay, so what we can apply now? Cos square x is 1 plus cos 2x, correct, by 2, okay, into d square minus 4. Okay, so then again what we will do? 1 over this one plus cos 2x over this one, right? So 1 by 2 if I are taking common, here we are getting 1 by d square minus 4 plus cos 2x divided by d square minus 4. Okay, then this is 1 by 2. So what will be this one? 1 by d square minus 4. Here we can assume that since 1 is there, we can write e to the power 0 into x, we can write, yes or no? So what is there? 0 is there in place of a. So here 0 square minus 4 we can write. So minus 1 by 4. Okay, plus cos 2x is there. So again, what the problem we are facing? This is 2 square minus 4. Again 0 we are getting. So this formula again we can apply. That is x by 2a. That is 2 into 2 is there, right? So 2 into 2 into sin ax. That is sin 2x, correct? So what will be the final answer? That is minus 1 by 8 plus this is also 2 to the 4 to the 8. Okay, sin 2x. Okay, so this is our particular integral and this is our complementary function. So general solution will be yc plus yb. Okay, here also we are applying this formula. Okay, so now we will proceed for the last one. Okay, so now we will see the question number 5. Okay, so that is dq plus 1 into y equal to e to the power x cos x plus sin 3x. Okay, so first of all, if we will see the complementary function, that is dq plus 1 is equal to 0. Okay, so one root we can get that is minus 1, right? So our complementary function will be c1 e to the power minus x, correct? So that is not a problem, but particular integral when we are finding, there it may create problem, but we will see. Okay, so that is e to the power x cos x plus sin 3x, okay, divided by dq plus 1. Okay, the next step will be e to the power x cos x over dq plus 1, correct, plus sin 3x divided by dq plus 1. Okay, there is no problem. Now since the product is there, e to the x into cos x, so here what we will do? We will apply d plus a whole cube. Okay, what is a? That is e to the power 1 into x is there. So e to the power x into 1 over d plus 1 whole cube plus 1 into cos x. Okay, plus here sin 3x is there. So what we will do? Sin 3x over d square into d we can write plus 1, dq we are writing d square into d. Okay, there is no problem. Okay, so now e to the power x cos x divided by d plus 1 whole cube, that is a cube, that is d cube, plus 1 plus 3d square, right, plus 3d, okay, plus here sin 3x divided by, this is minus 3 square, right, so this is minus d, okay, minus 3 square, so minus 9d, right, minus 9d plus 1, correct. So now, so 1 is missing here, right, so this one what we can write now, e to the power x cos x divided by this d cube we can write as d square into d, right, so plus 3d square plus 3d plus 1, this is plus 1, so we can write plus 2, right. So here what we can do now, this is 1 minus 9d is there, right, so in the both numerator and denominator we can multiply 1 plus 9d, correct, into this is sin 3x divided by, here that one will be a square minus b square, so 1 square minus 81 d square, correct. So this one if I will remove, there is no problem. So next step will be e to the power x, correct, so cos x is there, so that means cos into 1x, right, so here we can apply minus 1, right, cos x divided by, this is minus 1, right, so minus 1 into d, that is minus d, so again this is minus 1 into 3, that is minus 3 plus 3d plus 2, right, plus here what we will get, sin 3x into 1, so that will be sin 3x, right, so 9d sin 3x, that means first one time differentiation of sin 3x, right, so what we will do then, plus sign is there, right, so 9 into sin 3x derivative is cos 3x into 3, right, so 9 is there, so we can write 27 cos 3x, correct, whole divided by, here 1 square is there, minus 81 d square, that means 3 is there, so minus 3 square, that means 9, okay, so 9 into 81, that means minus minus, it will be plus, 9 into 81 is 9 1s are 9, 9 8 just 7 2, right, so that will be 7 2 9, okay. So what will be our next step, that is e to the power x cos x, 3d minus d is 2d minus 1, okay, so e to the power x cos x 2d minus 1, and here sin 3x plus 27 cos 3x divided by 730, okay. So again same problem here applying, so 1 minus 2d minus 1 in the numerator and denominator we can apply, okay. So e to the power x, this is 2d plus 1 cos x divided by 2d square, right, so that will be 4d square minus 1, okay, plus sin 3x plus 27 cos 3x divided by 730, so there is no problem, but here again 2d into cos x, right, so what will happen, 2 into first derivative of cos x is minus sin x, okay, into cos x, correct, so here 4d square, that means 4 into minus 1 square, that means minus 4 minus 1, that will be minus 5, correct, plus sin 3x plus 27 cos 3x divided by 730. Okay, so now our job is over. So what we can do now? So minus is taking common. If you are taking common, so this one will be e to the x power 5. That will be 2 sin x plus cos x, correct, plus sin 3x plus 27 cos 3x divided by 730. So this is the final answer for yp, and this is the final answer for yc. So our general solution will be yc plus yp. Okay, so hope you understood this problem. Here the problem was arising at here, that is e to the power x into cos x. Multiplication is there. So I hope you understood the process, the way I solved the problem. So here arbitrarily I have taken some collection of problems. Hope you understood. If you understood, then you can solve more and more problems which is available in the internet and different books. Okay, so thank you so much for watching this lecture.